Good morning. I am Pongodi, Assistant Professor, Physics Department. The subject is Application of Physics in Agriculture Engineering. The topic is Food Irradiation and Preservation. In this lecture, we are going to see about what is food preservation, why we need to preserve food, what are the types of food preservation, food irradiation, what are the sources used for food irradiation. First, let me see what is food preservation. Food preservation is the process of treating and handling food to stop or slow down food spoilage, loss of quality edibility or nutritional value, and thus allow for longer food storage. The primary objective of food preservative is to prevent food spoilage until it can be consumed. Food preservation is required to prevent food from being wasted, polluted, or spoiled. So next, why do we preserve food? The level of food loss is high, more than 40% for fruits and vegetables and higher for fish and meat. According to the United Nations, more than 30% of the mortality rate worldwide is caused by alimentary diseases. Alimentary diseases means common digestive disorders. Some agricultural products are important commodities in international trade. The presence of parasites, some microorganisms, yeast, and molds are also the source of problems. Food materials are damaged by a variety of elements such as the environment, microorganisms, rats, and other situations. Food preservation is required to prevent food from being wasted, polluted, or spoiled. Next, history of food preservation. There are many methods used for food preservation. Here are some of the methods pointed out. First one is drying. Drying or dehydrating food is a method of food preservation that removes enough moisture from the food so bacteria, yeast, and molds cannot grow. Next one is fermenting. Fermentation is the process of creating food or changing the properties of food using microbes. For example, fermenting vegetables allowed people living in places with harsh winters to eat them year round. Next method is salting. Salting is the process of preserving food with salt. Fruits can be preserved for a long time by salting them. Salting can also be used to preserve meats and fish. Next method is smoking. Smoking is a method of drying that allows imparts flavor to the food. Usually meat items are preserved by using this method, and smoke helps keep bacteria carrying insects away during the drying process. Next one is freezing. This involves lowering the temperature of the food below freezing point, usually minus 18 degrees Celsius to minus 35 degrees Celsius. Freezing stops the growth of microorganisms. Next method is canning. The process of placing foods in jars or cans and heating properly to a specified temperature is a way to preserve many different foods. Next one is refrigeration. This consists of keeping food at a temperature between 0 degrees Celsius to 8 degrees Celsius, close to freezing point. It is usually used for fresh food to slow down microbial growth. Next one is preservatives. Preservatives are added to food to fight spoilage caused by bacteria, molds, fungus, and yeast. Preservatives can keep food fresher for longer periods of time, extending shelf life. Pesticides. Some pesticides are used as a preservatives. Pesticides are widely used in producing food to control pests such as insects, rodents, weeds, bacteria, mold, and fungus. These are the oldest methods used for food preservation. The most advanced method nowadays used is irradiation. Method is food irradiation. Next we see what is food irradiation. What are the sources used for irradiation? What is irradiation? Irradiation is a technology that improves the safety and extends the shelf life of foods by reducing or eliminating microorganisms and insects. Like pasteurizing milk and canning fruits and vegetables, irradiation can make food safer for consumer. The process of treating food with a specific dosage of ionizing radiation. What is ionizing radiation? Ionizing means it can remove electrons from the atoms. That is, it can ionizing atoms. Example, X-ray, gamma ray. The exposure of biological materials, food commodities to radiation, more particularly to mutagenic radiation. Mutagenic means it may cause direct changes in a cell's DNA. Irradiation is a deliberate treatment of a product by exposing to gamma radiation from a radioactive source or to a machine-generated X-rays or electrons under controlled conditions. So, what we are understand here? What are the sources used for irradiation purpose? What are the sources? X-rays, gamma rays, and electron beams. What is food irradiation? Definition. Physical treatment that consists of exposing foods either prepackaged or in bulk to the direct action of electromagnetic rays. When made to bombard against materials that can knock off an electron from an atom or molecule, causing ionization. For this reason, these are often called ionizing radiation. What we are told in previous slide, the ionizing radiation is used for food irradiation process. So, this is the explanation of ionizing irradiation. The X-ray and gamma rays are very short wavelength radiations that have very high associated energy levels. That means why we are particularly using X-ray, gamma ray and electron beam for food irradiation, because these are very short wavelength with high energy levels. So we are using these as a source. This already we know. This is the electromagnetic spectrum. In this, these are the various types of radiations used for various applications. This is the visible range, infrared, microwaves and radio waves. These are the higher wavelength radiation with low energies. Right side, ultraviolet radiation, X-ray and gamma ray. These are lower wavelength radiation with high energies. These are the irradiation types: X-rays, UV rays, cosmic rays, microwaves, alpha particles, beta rays, and gamma rays. Mode of action, nature, and source of radiation. In previous slides, we saw that what are the types of radiations: alpha particles, beta rays, gamma rays, and X-rays are ionizing radiations. Ultraviolet rays and microwaves are non-ionizing radiation. Nature of radiation is particle nature and electromagnetic in nature. Alpha particles and beta rays are particle nature. Gamma rays, X-rays, UV rays and microwaves are electromagnetic in nature. These are the sources of radiation. For alpha particles, the source is helium-2 plus, beta rays, potassium, gamma rays, atomic nucleus, cobalt and cerium. For X-rays, tungsten, UV rays, sunlight, UV lamps, arc welding, and mercury vapor lamps. Microwaves, low frequency vacuum tubes. Next, what are the sources of irradiation? Already we said gamma rays, electron beams, and X-rays are the main source for irradiation. Gamma rays. Gamma rays come from the spontaneous disintegration of radionuclides. Gamma rays come from the spontaneous disintegration of radionuclides. The main source is cobalt 60, produced from cobalt 59. Next main source is cesium 137, a spent fuel from nuclear reactors. Some nuclear wastes produce gamma rays. The back end of the nuclear fuel cycle, mostly spent fuel rods, contains fission products that emit beta and gamma radiation. They have good penetration. Next, electron beams. Stream of high energy electrons propelled from an electron gun. Maximum energy 10 mega electron volt. Similar to beta particles, no waste in line equipment. Means electron beams are particle accelerators. In this case, the particles being accelerated are electrons and the beam generated is equivalent of beta radiation. An electron beam's size and power are best described by the voltage and current. The voltage is the force which accelerates the electrons. X-rays are produced by a beam of accelerated electrons is directed at a thin plate of gold or other metal, producing a stream of X-rays exciting from the other side. The energy is 5 mega electron volt. No waste is produced in this method. In line equipment, good penetration. Next is characteristics of irradiation source. Let me see what are the characteristics of the gamma ray, electron beams and X-rays. First, cobalt 60, that means gamma ray. The characteristics are high penetrating power, permanent radioactive source, high efficiency, source replacement needed, low throughput. Next, electron beams. low penetrating power, switch on, switch off capability, high efficiency, high throughput, power and cooling needed, technically complex. Next, X-rays. High penetrating power, switch on, switch off capability, low efficiency, high throughput, power and cooling needed, technically complex. Let me discuss some points about gamma rays. Already we know that cobalt 60 and cesium 137 are the main sources of gamma radiation. Cobalt 60, the choice for gamma radiation source, produced by neutron bombardment in a nuclear reactor of the metal cobalt 59, then doubly encapsulated in stainless steel pencils to prevent any leakage during its use in an irradiator. Cobalt 60 has a half-life of 5.3 years. These are highly penetrating and can be used to treat full boxes of fresh or frozen food. Over 80% of the cobalt 60 available in the world market is produced in Canada. Other producers are the Russian Republic of China, India and South Africa. Next is cesium-137. Cesium-137 is the only other gamma-emitting radionuclide suitable for industrial processing of materials. It can be obtained by reprocessing spent or used nuclear fuel elements and has a half-life of 30 years. There is no supply of commercial quantities of cesium-137. Next, electron beams. Since the associated energy levels of these rays are too low to be practical value in preservation, they need to be accelerated in cyclotrons, linear accelerators, etc. to make them acquire the required energy. Since electrons cannot penetrate very far into food, compared with gamma radiation or X-rays, they can be used only for treatment of thin packages of food and free-flowing or falling grains. Next, action of ionization radiation. Direct action, indirect action. Direct action, chemical events as a result of energy deposition on target molecule. Indirect action, radicals formed from radiolysis of water. Doses of irradiation. Doses of irradiation. The international unit of measurement is the gray, represented by GY. 1 gray represents 1 joule of energy absorbed per kilogram of irradiated product. 1 gray is equivalent to 100 radiation observed dose. The desired dose is achieved by the time of exposure and by the location of the product relative to the source. So it depends on the two quantities, time of exposure and the location of the product. Depend upon the mass, bulk density and thickness of the food. So the doses will vary depend upon the mass, bulk density and the thickness of the food. Different doses of food irradiation. The level of dosage is low dose, medium dose and high dose. First one, low dose applications. Range is less than 1 kilogram. Purpose of application. Low dose are used in inhibition of sprouting in potato and onion. Insect disinfestation in stored grain, pulses and products. So Low-dose irradiation is used to inhibition of sprouting potatoes and onion, insect disinfestation in stored grain pulses and product. Next one, medium dose irradiations range is 1 to 10 kilogram. Purpose of application is elimination of spoilage microbes in fresh fruits, meat and poultry. Elimination of food pathogens. Control of microbes in spices and herbs. So medium dose irradiation is used for the application of elimination of spoilage microbes in fresh fruits, meat and poultry, elimination of food pathogens, control of microbes in spices and herbs. Last one is high dose. High dose irradiations are in the range of above 10 kilogram. The purpose of applications are sterilization of food, shelf stable foods without refrigeration. So two main purpose, sterilization of food. Next one is the self stable foods without refrigeration. So next we mainly see about which foods are irradiated. Some kinds of food alone have been irradiated. Some examples are wheat flour to control of mold. So what purpose we need to irradiate the wheat flour means to control of mold. Second one, white potatoes. Potatoes are mainly irradiated to prevent the sprouting. That means inhibit sprouting. Next, pork. Pork is irradiated because kill Trichina parasites. Fruits and vegetables. Fruits and vegetables are irradiated to prevent insect control and increase shelf life. Next, herbs and spices. Herbs and spices are irradiated for sterilization purpose. For sterilization purpose. Next, poultry. Poultry items are irradiated for bacterial pathogen reduction. Next, meat items. Bacterial pathogen reduction. So next we see what changes occur in the quality of irradiated foods. Irradiation is a cold process. Little, if any, change in physical appearance. No textural or color changes as with traditional heat preservation. Possible chemical changes or flavors, tissue softening. So, irradiation causes minimal changes to the chemical composition of the food. However, it can alter the nutrient content of some foods because it reduces the level of some of the B group vitamins. Next, we see what are the advantages of irradiation. First one is minimize food losses, improve public health, increase international trade, an alternative to fumigation of food, increase energy saving. So, it can kill many insects and pests that infest foods. It can delay or stop normal ripening and decay processes so that foods can be stored for longer. It can kill dangerous microorganisms in foods. minimize food losses. Especially in the third world, irradiation has high potential where in many cases food is spoiled during post-harvest stage. So food preservation, delayed ripening, sprout inhibition, disinfestation. These are the main advantages of food irradiation. Next, let me see what is ionizing and non-ionizing. Enough energy to remove tightly bound electrons from atoms, thus creating ions. Example, X-rays and gamma rays. Non-ionizing radiations. Not enough energy to remove electrons but causes atoms to vibrate. Example, sound waves, visible light, UV and microwaves. Next, let me see why gamma rays mostly used in food irradiation. Ionizing radiations penetrate the food to vary in degrees depending on the nature of the food and the characteristics of the radiations. So these are the representation of the penetrating power of the different radiations: gamma ray, beta ray and alpha ray. Among these three, gamma ray has a high penetrating power when compared to beta and alpha ray. So gamma ray is used for the food irradiation purpose. Next, why food irradiation need? For increasing concern over foodborne diseases and uses of certain chemicals in food. High post-harvest food losses from infestation, contamination and microbial spoilage. Stringent regulations related to quality and quarantine in international trade in food products. How irradiation works. The irradiation process happens after your food is produced and packaged. Food enters a chamber where it is exposed to a specific amount of radiation. The radiation penetrates the food and kills germs or prevents them from multiplying. But what is happening inside means by disrupting the biological processes that lead to decay. In their interaction with water and other molecules that make up food and living organisms, radiation energy is absorbed by the molecules they contact. The reactions with the DNA cause the death of microorganisms and insects and impact the ability of potato and onion to sprout. Next, the biological effect of ionizing radiation. The biological effect of ionizing radiation on the cell, normal and pathologically changed. The contents are the biological effect of ionizing radiation, the sources of ionizing radiation, the properties of ionizing radiation, the dependence of biological effects of ionizing radiation from the type, dose and energy, the characteristics of ionization and excitation, mechanism of the influence of ionizing radiation on the living objects, the levels of metabolic changes in the organisms, mutagenic ability of radiation, individual and specific sensitivity, the dependence of radiosensitivity from environmental conditions. When we study about the radiation, we know the term radiology. We know about radiology. Radiology consists of radiation genetics, biochemistry, ecology, hygiene, immunology, anti-radiation protection and treatment, cosmic radiology, radiobiology of tumors. Polluted air leads to respiratory system diseases. Contaminated food and water affect GIT. GIT means gastrointestinal tract is a part of digestive system. Pollution of human body surface skin diseases. Biological effect of ionizing radiation is the reaction of organisms as answer of radiation, which manifests by morphologic, functional, metabolic changes in all the levels of its organization. That means atomic, molecular, cellular, tissular, organ and organism. The source of ionizing radiation is an object which consists of radioactive material, technical device that can radiate ionizing radiation. There are natural and artificial sources of radiation. Natural. First, let me see what are the natural sources. Space from space form. Natural form is space form. Background protons, neutrons, nucleus of atoms has comparatively high energy decreased with the presence of atmosphere, low on Earth's surface. Artificial devices made by humans, X-ray tubes, radioactive nuclides are formed in nuclear reactors, generators, and charged particle accelerators. Next, we see characteristics of ionizing radiation. First, ability to penetrate through the large and thick objects, not penetrate through the not transparent. Ionize air and molecules of living organisms. It is because of its energy of light 0.5 electron volt, alpha particle 10 mega electron volt, ionizing ability 20,000 pairs of ions per mm, maximal ionizing effect and biological influence. Ability to activate photomaterials in dosimetry. Dosimetry means dosage of radiation observed by the substance. Scintillation. Scintillation means rapid changes in the brightness. Ability to accumulate and cause distant effects. We don't feel radiation. Ionizing radiation is spreading linearly, causing interference and refraction. First stage. First stage of ionizing radiation. Physical process of the interactions between the radiation and substance. As a result of this interaction, we have excited and ionized atoms and molecules that have high chemical activity. They interact between each other and with surrounding atoms. In this case, a large amount of highly active free radicals and peroxides appear. The ionization is the separation of electron from atom. If the energy given to the atom is not enough to separate the electrons, this electron changes its position to the outer orbit and becomes excited. This is the first stage of ionizing radiation. Next, second stage. In second stage, the radiation and chemical process which leads to a charge of a structure of molecules and as a result to the biochemistry of cell disorders. Radiolysis formation of free radicals which are highly active because they have an insufficient number of electrons. Chain reaction. The larger the molecule, the higher its ability to be ionized. Process of inactivation of enzymes. OH groups and SH groups come together. Mechanisms of action of ionizing radiation. The direct effect of ionizing radiation. Cases where radiation directly causes changes. Ionization, excitation, radiolysis of water and the formation of radicals. The direct effect of radiation, because the radiation of a cell damage is the result of the direct effects of ionizing particles, or gamma quantum is particularly sensitive to the amount of cells, primarily in the nucleus, resulting in its inactivation and destruction. It could be other cell organelles. Next, indirect effect of ionizing radiation. When fragments of molecules oxidizing radicals OH, H2O2, HO2 ions, the primary lipid peroxidation radiotoxins type, quinones interact with intact molecules, joining them and changing their structure and properties. Oxidative radical steps are easy to sulfhydryl groups of enzymes and DNA. This can cause them to rupture, not contain attachment, and the other two to form active radicals as a result of possible chain reaction. For example, disintegrated molecule 1 and 2 was formed radicals. They interact with two intact molecules, which in turn break down into four radicals, etc. Therefore, a small amount of primary energy is so great effects in the body. This is the physical and chemical and biochemical level damage. These processes occur in the cells, tissues, and organs. So, functional and morphological changes in the cells of a living organism that occur under the influence of organizing radiations can be caused by two mechanisms: direct action of radiation, ionization and excitation of atoms and molecules irradiated cells of the body, and indirectly influence of radicals formed by the area of exposure. The last one is a seed processing. The seed material to be processed should be properly conditioned and pre-cleaned by removing the seed appendages and particles such as trash, stones, clots, etc., which are larger in size than the desirable crop seed, so as to increase the speed and efficiency of processing equipments. Seed processing means improving the quality of harvested seed, including several operations starting from harvesting of seed crop till its marketing. Objectives of seed processing. These are the main objectives: to improve seed quality through removal of adulterants, non-seed material, broken seeds; to maintain seed viability and vigor; to make seed handling easy; to increase real value of seed. Real value equal to purity percentage into germination percentage divided by 100. Methods used for seed processing: seed drying, seed cleaning, seed grading, seed packaging, and seed labeling. These are the methods used for seed processing. Seed drying. Reduction in seed moisture content to a safer limit is called seed drying. Its objective is to maintain seed viability and seed vigor for longer period of time during storage. If moisture contents are high, higher chances of insect pests attack and deteriorate quality of seed due to higher respiratory activities. There are two types of drying, natural drying and artificial drying. In natural drying, seeds are spread uniformly at neat and clean place and dry under the natural condition, that is under the sun. In artificial drying, the dryers used for the drying purpose. Seed cleaning. Separation of physical impurities or removal of non-seed material from seed. Wet cleaning and dry cleaning. Seed grading. Removal of undersized, underweight seeds from seed lot. Grading is done on the basis of length, width, thickness and density of seed. Seed treatment. Seed treatment refers to exposure of seed to certain chemical or physical agents which are able to protect them from pests and provide good health to the seed. Infected seeds may fail to germinate. Infected seeds lead to introduction of pathogens into new areas. Seed packaging. Seeds are packaged in packs of appropriate quality and size. Choice of packaging material depends upon type of crop, amount of seed and storage conditions. Packaging materials are of three types: moisture, vapor resistance, example polythene; moisture, vapor permeable, example cloth or paper bags; moisture vapor proof, example tin cans. Now we are discussing about the processing of seed, spice, fruits and vegetables. In this list, next we see about spice. A spice is a seed, fruit, root, bark or other plant substance primarily used for flavoring, coloring or preserving food. Many spices have antimicrobial properties. Spices are sometimes used in medicine, religious rituals, cosmetics, or perfume production, or as a vegetable. The spice trade developed throughout South Asia and Middle East by at least 2000 BCE with cinnamon and black pepper, and in East Asia with herbs and pepper. The word spice comes from the Old French word espice. Spices were among the most demanded and expensive products available in Europe in the Middle Ages, the most common being black pepper, cinnamon. Spices were all imported from plantations in Asia and Africa, which made them expensive. The control of trade routes and the spice producing regions were the main reasons the Portuguese navigator Vasco da Gama sailed to India in 1499. There are variety of spice items. Some examples are major spices, black pepper, chilies, ginger, turmeric. Speed spices, example coriander, celery, fennel and cumin. Tree spices, clove, nutmeg, cocoa. Herbal spices, example thyme, marjoram. Mixed spices, garlic, peppercorn and saffron. The growing. The growing of spice items are explained here. Black pepper growing states Kerala, Karnataka and Tamil Nadu. Harvest period of black pepper is November to January and January to March. Ginger growing states Kerala, Meghalaya, Arunachal Pradesh, Mizoram, Sikkim, Nagaland and Orissa. The harvest period of ginger is January to February. Turmeric growing states are Andhra Pradesh, Orissa, Karnataka, Tamil Nadu and Maharashtra. Harvest period of turmeric is February to May. Red chilies. Red chilies are growing in Andhra Pradesh, Maharashtra, Karnataka. The harvest period of red chilies are December to May. Nutmeg. Growing states are Kerala, Tamil Nadu, and their harvest period is May to August. Cumin. Growing states Gujarat and Rajasthan. Harvest period is February to May. This picture shows the various machineries used for pre-processing. Next, cleaning. The crop should be cleaned before processing. The first stage is to remove dust and dirt using a winnowing basket. After winnowing, the crop needs to be washed in water. The water must be changed regularly to prevent recontamination of spices by dirty water. So the first step of cleaning is winnowing. So next, washing. Next, frequently we need to change the dirty water to prevent the recontamination. After cleaning, next drying. This is by far the most important stage in the process to ensure good quality spices. Inadequately dried produce will lead to mold growth. During the dry season, sun drying is usually adequate to dry the produce. During the wet season or times of high humidity, which often coincides with the harvest of the spices, a solar dryer or sun drying cannot be used effectively. An artificial dryer that uses a cheap energy source is necessary. So in drying process, there are two types of drying. First one is a natural drying, second one is a artificial drying. Degree of processing. Spices are produced from large variety of plant parts such as rhizomes, pods, leaves, fruits, seeds, etc. Few spices can be incorporated directly into food. The degree of fitness of processed spices depend on its ultimate use. Next, grinding. The word grind means reducing the matter to small particles or powder by crushing it. Grinding of spice is a process which reduces the solid matter of spices to small or powdery form. Grinding may also add value to the spices. The main reason people choose to grind their own spice is freshness. While even ground spices should keep quite well for a year or more if stored properly, they do tend to lose their flavor and aroma more quickly than whole spices. Grinding products. There are variety of grinding products. Some examples are here. Straight spice powders. Example, chili powder, turmeric powder, coriander powder, pepper powder, cumin powder, etc. Culinary powders. Example, sambar powder, rasam powder, etc. Masala blends. Example, garam masala, chicken masala, meat masala, etc. Seasoning and taste makers. Example, snack seasonings. Masala munch, green chili masala, sour cream onion, mint, etc. And pasta and noodles taste makers, etc. Soup mixes, blends. Soup powders. Advantages of grinding the spices: higher production rate, lower energy consumption, fine particle size, more uniform particle distribution, low grinding cost, no heat generation. Irradiation of spices. Gamma rays, electron beam, X-rays are important and effective methods for spice decontamination. Doses of 3 to 10 kg is used to ensure the microbial safety of spices. Irradiation is allowed for decontamination of dried herbs, spices, and vegetable seasoning. There may be the formation of low molecular weight, volatile or non-volatile radiolysis products emanating from packaging material. Till now we have seen about the processing of seeds and spices. Let we see about processing of fruits and vegetables. Fruits are a high moisture, generally acidic food that is relatively easy to process and that offers a variety of flavor, aroma, color and texture to the diet. Vegetables consist of a large group of plants consumed as food. Perishable when fresh but able to be preserved by a number of processing methods, they are excellent sources of certain minerals and vitamins and are often the main source of dietary fiber. Next, processing of fruits and vegetables. Methods of processing. Processing of fruits and vegetables is very important to produce products for direct consumption and as food ingredients. There are three major processes: canning, freezing, and drying. Canning is defined as the preservation of foods in hermetically sealed containers and usually implies heat treatment as the principal factor in prevention of spoilage. Canning was invented by Nicholas Appert in 1910, so also termed as Appertration. Foods that are canned: low acid foods, high acid foods. Meat, fish, poultry, dairy fall into pH range of 5 to 6.8. This large group is commonly referred to as the low acid groups, acid foods, with pH values of 4.5 and 3.7. Fruits such as pear, oranges, apricots, and tomatoes fall in this class. High acid foods such as pickled products and fermented foods. The pH values range from 3.7 down to 2.3. Also, jams and jellies are in these classifications. Principle of canning: destruction of spoilage microorganism within the container by means of heat. Process: selection of fruits and vegetables. Fruits and vegetables should be absolutely fresh. Grading: the selected fruits and vegetables are graded according to size and color to obtain uniform quality. Washing: It is important to remove pesticide spray, residue and dust from fruits and vegetables. Peeling. The objective of peeling is to remove the outer layer. Peeling may be done in various ways: hand peeling, steam peeling, mechanical peeling, light peeling. So these are the process of seeds, fruits and vegetables. Cutting, blanching, cooling, filling, sealing, processing, cooling and storage. These are the various steps. Next method is freezing. Easy, convenient and the least time consuming method. Slows growth of microorganisms and chemical changes. Preserves the greatest quantity of nutrients. Freezing overview. Frozen in many forms: whole, sliced, crushed and juiced, etc. The food materials can taken in the different forms. It may be whole or sliced or crushed or juiced. Best quality. Choose fully ripe but fine fruit. Immature or overripe produce lower quality when frozen. Types of packs: syrup pack, sugar pack, dry pack, unsweetened and water packs. For vegetables, dry and tray pack. Vegetables. Thawing for serving. Most vegetables can be cooked without thawing. Thawing means to make something become soft or liquid again after freezing. Corn on the cob should be partially thawed before cooking so that it will heat all the way through. Leafy greens cook more evenly if partially thawed. Storage times. Fruits. Most frozen fruits maintain high quality for 8 to 12 months. Unsweetened fruits lose quality faster than fruits packed in sugar or sugar syrups. Vegetables. Most vegetables will maintain high quality for 12 to 18 months at 0 degree Fahrenheit or lower. Use your home frozen vegetables before the next year's crop is ready for freezing. Drying method. One of the oldest methods of preserving food. Alternative to canning and freezing. Simple and safe, easy to learn. No refrigeration needed. Takes little space. Removes moisture from food so bacteria, yeast and molds can't grow and spoil food. Slows down action of enzymes but doesn't inactivate them. Factors. Surface area: the greater the faster the product dries. Temperature: the greater the difference between the product and the drying medium, the greater the rate of drying. Humidity: the higher the slower the drying. Atmospheric pressure: the lower the temperature required to remove water. So these are the factors we have to see during the drying method: surface area, temperature, humidity and atmospheric pressure. Binding of water. As a product dries, its free water is removed. This water evaporates first. Water in colloidal gels such as starch, pectin or other gums is more difficult to remove. Water that is most difficult to remove is that chemically bound in the form of hydrates. So there are different methods for drying: sun drying, spray drying, tray drying, and tunnel drying. Benefits of drying: takes great, less expensive, less portable, reduces waste, flexible and versatile, efficient storing. So in this lecture we have seen about the food preservation, why need to preserve food, what are the types of food preservation, food irradiation, what are the sources used for food irradiation, gamma radiation, all the X-rays and electron beam radiation. Finally, the processing of seeds, spices, fruits and vegetables. Thank you.